Okay, on worksheet number 2, the LOL worksheet number 2, we are going to do number 3 so that everybody can understand. Number 3 is the hardest one. So we have to look through what it's actually telling us. There's a pan of water that's at 25 degrees Celsius. That is the temperature of the room. So it's at room temperature. We're going to heat it to boiling, and then the water is going to boil away. We need to do separate LOL charts because each set of LOL charts is going to represent one segment on the heating curve we're going to learn next week. Okay, so it's a week after next, excuse me. So let's go through and start from the beginning. When I'm adding heat to water at 25 degrees Celsius, water is my system. If it starts at 25 degrees Celsius, that's room temperature. We're going to assume that it's not really warm. It's actually pretty cold. Okay. It's in a liquid state. And as we stated, liquid has two boxes. If it was a gas, it would have one box. If it's a liquid, it has two. If it's a solid, it's one box. Liquid is two, and a gas has four. I can't even talk anymore. Probably because I'm recording it, right? All right. Is this water going to change states while it's warming up? No, it does not. So it will still be a liquid. Is this water gaining temperature as we heat it up? We're going to get this all the way to boiling. How many whooshes would you put on boiling water? I put 3. So since I put 3 whooshes, I would put 3 boxes here. Now, did I gain, lose, or stay the same as far as energy goes? I gained energy, so I should have an arrow going into the system. This shows the direction that the energy is flowing into the system. The water is gaining this energy. How much energy did it gain? It gained 2 boxes worth of energy. Everybody cool with that one so far? All right. The second part is when I go into the stage where it's going to start undergoing a phase change. It's still water. It's at 100 degrees, so it's hot. It's still a liquid here. But now what's it doing? Is its temperature going to change during the phase change? No. So we're going to stay at 3 boxes for ETH. Is the number of boxes for EPH going to change when it undergoes the phase change? Yes. What is the number of boxes we use for a gas? We use 4. So we're going 1, 2, 3, 4. Which way is the energy flowing? Is it going into the system or out of the system? It's going into the system, right? How many boxes went into the system for us to boil this water away? We have 2 more boxes added on. Okay. This first line is for the first set. What was the arrangement of molecules? What was its state of matter? Did it change states or is it staying constant? It was a liquid the whole time, right? So we would write liquid here. What about the motion of the particles? Did the motion of particles change? Yes. What did we start at? We started at slow. And then we went to what? Went too fast. Okay. This one over here is for the water boiling now. What is the state of matter? Is it constant or does the state of matter change? This one it is a change, so it's liquid to a gas. Does the motion of particles change? No. This is still going to be a fast. So reminder, we're going to have 1 box for a solid. We're going to have 2 boxes for a liquid. And we're going to have 4 boxes for a gas. Now, I want to show you guys how this connects to what we've already been doing. If I look at this right here, I see that I have a liquid that is moving slow. So if I were to draw a particle picture, I would have a liquid that's moving slow. It's going to become a liquid that is moving fast. Everybody cool with that? This one, we start with a liquid moving fast, and we end with a gas that's moving fast. That's our particle pictures. This is what we've been doing. It's exactly the same thing. It's just a different way of representing the same thing. Does everybody understand that? The only difference is the particle pictures does not allow us to show which direction the energy is flowing and how much energy is actually flowing. That's why we use the LOL charts. That's why the directional arrow going into the system is the most important thing for this. Everybody cool with that? All right.